Azure Virtual Machines are one of several types of on-demand scalable computing resources that Azure offers. Typically, you can choose a virtual machine when you need more control over the computing environment than the other choices offer. An Azure Virtual Machine gives you the flexibility of virtualization without having to buy and maintain the physical hardware that runs it. However, you still need to maintain the virtual machine by performing tasks such as configuring, patching, and installing the software that runs on it. Virtual machines are part of infrastructure as a service offerings on Azure. You manage everything except the hardware. You have complete control of what operating system to run, which applications to install, and how to maintain it all. Microsoft Azure will provide the networking for the virtual machine as well. Compared to buying your own hardware and running your own servers with Azure, you get additional tooling to manage up to thousands of virtual machines. Use the Azure portal to control your hybrid cloud that could include virtual machines on Azure and on premises. You can ensure virtual machine compliance with your company guidelines by using blueprints. These are templates for how virtual machines should be created. Azure will recommend improvements and changes to ensure high availability, security, performance, and lower costs. Virtual machines can run Windows or Linux in a large range of configurations and setups. Containers are executable units of software in which application code is packaged along with its libraries and dependencies so it can be run anywhere, whether on the desktop, traditional IT, or the cloud. There are a number of features that you get with containers, such as you can manage application dependencies. All the dependencies for an application are included in the container image. You can manage the application and its dependencies with confidence. You have increased portability. Applications running in containers can be deployed easily to multiple different operating systems and hardware platforms. You have consistency. The operations team can rely on containers being the same every time, no matter which target they are being deployed to. There is less overhead associated with containers. Virtual machines require a lot more maintenance and updates. Containers don't have any components relating to the operating system that require maintenance. And lastly, you have a lot more efficiency. Development, deployment, and maintenance are all more efficient when using containers. Scaling and patching is significantly simpler. How is the workflow managed in containers? You develop a software as normal. You go through the various cycles of creating your application, and when you are ready to publish it, the application gets wrapped up in a container image which can then be deployed or published to something like Azure Container Instances. Let's look into some details of Azure Container Instances. Azure Container Instances is the primary service on Azure for hosting and running your workloads in a container. Workload is another word for process, application, or any other compute function that you might have. With ACI, you can run your containers, meaning run the application inside of the container, without managing any virtual machines. You can use containerized applications to process data on demand by only creating the container image when you need it. Spin up the instance, process your data, and then shut the container down again. This will both save money and resources. And this is all done through the Azure portal, the Azure CLI, or PowerShell. It is quick and relatively simple to use. Let's understand Azure Functions. The easiest way to understand it is to compare it to something that we already know: infrastructure as a service and platform as a service. On a virtual machine, you install your own applications and programs, and you have access to the operating system. You can see all of the resources available to you. For Azure App Services, you have a web application, and you can monitor the whole application. You don't have access to the machine it is running on, but you can see the processes and other details. An Azure function is the smallest and largest compute service on Azure. As the name implies, it is a single function of compute, a single action that happens when its unique web address is hit. When an application or user on the internet calls the Azure function or invokes it, it is done via a web address. This unique address triggers the function, which then runs once and processes the request. It can talk to other Azure services, call more Azure functions, provide a reply, or something else. Once the function has finished, that's it. Nothing else happens until it is called again. A function just does one run and one unit of compute. So how do they work then? Functions still use a virtual machine to run on. After all, the compute has to happen somewhere. But you don't have to worry about the maintenance, process, or anything else. It's a serverless compute service. You just have to focus on your functionality. Microsoft Azure VM skill sets are groups of individual virtual machines within the Microsoft Azure public cloud that information technology administrators can configure and manage as a single unit. Administrators can use Azure VM skill sets to deploy complete services rather than duplicate the same VMs. For example, an Azure VM skill set for a web application service might include web servers, application servers, database servers, network address translation servers, load balancers, and other functionality. With Azure VM skill sets, all of those instances can be deployed as a unit, allowing administrators to grow and manage VMs as a higher level service, rather than cobble them together manually. Although Azure VM skill sets are usually deployed as a group, administrators can access and interact with individual virtual machines if necessary to monitor and tweak the individual instances. There are a number of benefits associated with using skill sets. Having multiple virtual machines is one of them. It is simple to manage multiple identical virtual machines using a load balancer. Skill sets also provide high availability. If one VM fails or stops, the others in the skill set will keep working. You have auto-scaling in skill sets, which means that you can automatically match demand by adding or removing virtual machines from the skill set. You can have operations on a very large scale and run up to 1,000 virtual machines in a single skill set. There is no additional cost, and there is no added cost for using skill sets in itself. Use any virtual machine size and configuration you want in Azure to host the Windows 10 instance, except a Linux machine, of course. Once deployed, you can access it from any device that has web access and a modern web client. This includes Windows devices, Mac OS, Linux, smartphones, and more. Azure Virtual Desktop is a completely virtualized version of Windows, meaning it runs 100% on the cloud. It reuses Windows 10, it provides concurrency, it can be accessed from anywhere, and it has secure data. Multiple users can use Windows 10 and 11 from Azure Storage. This will reduce costs and streamline license usage. This VM can be accessed from anywhere and on any device with an internet browser. An availability set is a logical grouping of virtual machines that allows Azure to understand how your application is built to provide for redundancy and availability. We recommend that 2 or more VMs are created within an availability set to provide for a highly available application and to meet 99.95% Azure SLA. There is no cost for the availability set itself. You only pay for each VM instance that you create. Each virtual machine in your availability set is assigned an update domain and a fault domain by the underlying Azure platform. Each availability set can be configured with up to 3 fault domains and 20 update domains. These configurations can't be changed once the availability set has been created. Update domains indicate groups of virtual machines and underlying physical hardware that can be rebooted at the same time. When more than 5 virtual machines are configured within a single availability set with 5 update domains, the 6th virtual machine is placed into the same update domain as the first virtual machine, the 7th in the same update domain as the second virtual machine, and so on. The order of update domains being rebooted may not proceed sequentially during planned maintenance, but only one update domain is rebooted at a time. A rebooted update domain is given 30 minutes to recover before maintenance is initiated on a different update domain. Fault domains define the group of virtual machines that share a common power source and network switch. By default, the virtual machines configured within your availability set are separated across up to 3 fault domains. While placing your virtual machines into an availability set doesn't protect your application from operating system or application-specific failures, it does limit the impact of potential physical hardware failures, network outages, or power interruptions. VMs are also aligned with disk fault domains. This alignment ensures that all the managed disks attached to a VM are within the same fault domains. Only VMs with managed disks can be created in a managed availability set. The number of managed disk fault domains varies by region, either 2 or 3 managed disk fault domains per region.
In this demo, we are going to create a new app service on Azure. So let's get started. From the portal, I'm going to use one of these shortcuts on the front page, or you can search for the service you're looking for in the search bar above. And then I'm gonna hit create. Now you can create your own new resource group, but I'm going to use the one I already have. And then we need to give the new web app or app service a name. And this has to be a unique name across all of Azure, not just your own subscription, because it would get a unique web address. You can see it gets a green tick, which means that yes, we are okay to use that name. I can choose to publish a code or Docker container. We can also select the runtime stack. I'm going to choose .NET 6 operating system Windows. In region, we're going to select a region as always for a resource. I'm going to go with the US East one. And now we have the app service plan. The app service is your website, that's your resource. The app service plan is more like your server or your VM. So we can create a new one, or it's already suggested a name for us, which is fine if you want to do that, or we can choose to create our own. Since I'm on a free tier, I can only choose to create the free app service plan. Of course, if we're on the pay-as-you-go plan or pay plan, I can choose many other types of VMs and app service plans. Now let's move forward to the next section, which is deployment. We don't have much to change here, so let's just skip to the next section. Web apps can be made public or isolated based on inbound and outbound traffic rules. By default, this app is open to the internet. I leave it like this and move forward. Here, I can choose to enable or disable App Insights. Application Insights is an extension to Azure Monitor and provides application performance monitoring features. APM tools are useful to monitor applications from development through test and into production. Then we have the last section, that is tags. Tags help to categorize resources. I'll just add a single tag and go to review and create. Now I'll just click on create to create a new web app and wait for the deployment to complete. Deployment of resources can take up to a few minutes. So I'll just pause the video here until the deployment is completed. And now our deployment has succeeded. Let's go to the resource, and here are all the various properties of the particular app service. Now the interesting one here is the URL. If I click on that and I open it in a new tab, we're going to load up the website that was just created. So this is the app service running on the app service plan. So that's how you create an app service. But as always, before ending the lab, let's just go and clean up. Don't forget to clean up resources if you're not using them. So we're going to go back and delete everything we no longer need, like our resource group and the web app we just created. That's all for this lab. In this video, we'll learn how to create and connect to a Azure Windows virtual machine. So let's get started. From Azure Services on the Azure portal, click on Virtual Machines. Here, click on Create to create a new virtual machine. Now we need to fill in these details. First, select a resource group that you've already created, or you can create a new resource group here. Then choose a unique name for your virtual machine and your desired region. And then select the security type. I'll go with the standard one. Then you need to select the image for your virtual machine. I'll be using the Windows one. I'll keep the x86 architecture and then I'm going to select the size of the server, which can also be changed later. For now, I'm going to stick with the 8 GB one. The Windows virtual machines always need a username and password for you to sign into them later. So take a note of the username and password you're selecting here. Here in the next step, you can choose the type of traffic flow you need in your virtual machine. You can always allow or block the inbound port traffic. I'm leaving the RDP port open here because I'll be using this port to log into the virtual machine later. Now that we're done, I can click on next to check on the disk settings. Here you can select the OS disk type. I'll be using the standard HDD disk. Then you can choose which encryption method you're going to use. You can choose the Azure managed key, which is encryption at rest, which is the default option. Or you can choose to manage your key yourself, or you can choose the double encryption method. I'll just stick to the standard one. Next is networking. So every virtual machine needs to exist in a virtual network. If you don't already have a virtual network set up, you can create a new one here or you can use the default one made by Azure. I'll stick to the default one. And here again, you can choose the inbound traffic rules for your virtual machine. I'll just allow the RDP port and then click on next. Now you can also choose to set up the diagnostics for your virtual machine. I'll just go with the default options here. You can also choose to set up Azure Active Directory. You can also enable auto shutdown and alerts for your virtual machine. In the Advanced tab, you can choose to add an extension to your virtual machine from many third-party applications, for instance PowerShell for running scripts, etc. But for now, we don't need any in this lab. Azure Dedicated Host is an Azure service that provides physical servers able to host one or more Azure virtual machines dedicated to your organization and your workloads only. This is obviously more expensive, so choose only if you need to. Next, a proximity placement group is a logical grouping used to make sure that Azure compute resources are physically located close to each other. Next, we have the Tags tab. Here you can add metadata about your virtual machine. I'm just adding the name of skill curve. You can use these tags in order to identify your virtual machine later. Now I'll just review everything and click on create once done. Creation and deployment of resources can take some time, so I'll just pause the video until then and come back when the deployment is completed. Okay, so deployment is now completed. We can go back to the virtual machine resource that we've created. And let's observe everything that we have here. We can see the status as running. I'll just copy the public IP address because we need it for the connection. I'll open the remote desktop connection option from my own PC and enter the public IP address. And then it will ask me for the credentials that I made for this virtual machine. And as I enter those credentials, I am now logged into my own virtual machine. The next step is to click on Server Manager and add roles and features. Click on Next, keep it selected and click on Next. Click on Next again. Now here from the server rules, select Web Server IIS if it is not already installed. Click on Add Feature and then click on Next. Once the features get installed, you can just close this window and then open Internet Explorer. Now type in HTTP localhost and you should be able to see a default browser window opening, and here it is. Now let's do the same thing, web browser of your own machine. Instead of writing localhost, I'll type in the public IP address of my virtual machine. But this page is not loading, but it has a reason. This is happening because we don't have port 80 opened in the inbound rule section. So I'll just go into networking and open the port 80 of my virtual machine and then try to do the same thing again. And now it's running completely fine. Now before I end the lab, we have one last step to follow. I want to modify this web browser page. So for that, I'll go back to the remote session host, go into the C drive, go to the inetpub folder and then into the root folder. Here I'll create a new text document with my custom text. Rename the text file to index and save it as an HTML file. Now it's a web page. Now let's test it. When I refresh the page, I'll see my custom text. I can do that same thing in the web browser of my own machine. I can see the text here. Now that's all we had for this lab. But before ending the lab, I would like to delete all of the resources that I created during this lab, as most of them are billable.